You are welcome to Instructor Victor's tutorial. Today, I'll be starting a topic. I'll be giving an introduction to a topic which is differential equation. And to lay the emphasis on differential equation before embarking on its definition and explanation, we all know that most of the laws that we find today in physics are all gotten from differential equation. And these differential equations are the main topic or the most required topic a science and engineering student is expected to know very well in order to excel in his or her field of study. Now, understanding differential equation is essential in understanding every other thing that you need to know in science and engineering class. Now, one can say that mathematics is a language that engineering and science use. Yes, but differential equation is one of the most essential language which is needed for engineering and science as far as they are concerned. Now, let us go deep into the meaning of differential equation. Now, one can deduce or deduct from his point of view that a differential equation is any equation which involves a function and its derivative. Now, if you are watching this video, I would want you to bring out your jotter or your book and be jotting what I'll be saying here, because after today's class, which is an introduction class, I will not give any GST explanation concerning differential equation. All is about calculation. So understanding the basis of what differential equation is will help you furthermore on the calculations that are involved in them. Now, a differential equation is any equation which involves a function and its derivative. A differential equation, let me use DE, is any equation that involves a function and its derivatives. Now, how do we classify differential equation or its types? Differential equations are of two types. Before I will explain the meaning of this differential equation, I will first of all bring out the types, and then from there I'll start giving you the emphasis on why a differential equation is any equation that involves a function and its derivatives. Now, what do you do? The types of differential equation that we have are, we have the ordinary differential equation. One of the types of differential equation, we have the ordinary differential equation. I'll be using the shortcut DE. It means differential equation. And then we have the second one, which is the partial differential equation. Now, the one that we'll be studying most or will be touching more especially is that of the ordinary differential equation, because in ordinary differential equation there are so many other subtopics or sub types or subclasses of differential equation that can be found under ordinary differential equation. So for our main class or for our further classes, we'll be talking more on what the ordinary differential equation. But then I will have to give you the relationship or give you the difference between the ordinary differential equation and the partial differential equation. Now, note these keywords which I'm about to use now to give you the meaning of what ordinary differential equation and the partial differential equation. Now, for you to explain the meaning of ordinary differential equation, you have to go this way. Now, an ordinary differential equation is any equation that its ordinary derivative has one or more dependent variable. Now, look at it. It has one or more dependent what? Variable with respect to a single independent variable. With respect to a single independent what? Variable. Single independent variable. Now, you may be asking, what is a dependent variable and what an independent variable? I will explain that. But then I will have to give you the meaning of partial differential equation. A partial differential equation is any equation that its partial derivative is one or more, or has one or more dependent variables with respect to more than one independent what? Variables. Now, this is what I mean. It has one or more dependent variables, just as this one has one or more dependent what? Variables. But that of ordinary is with respect to single independent variable. But that of partial differential what? Equation is what? Is with a respect to more than one independent what? Variable. Now, if you are with your notes and you are writing, I'm sure you should note the little difference between the ordinary differential equation and partial differential equation. Now, I'll be giving an example to elaborate more, emphasize more on this types of differential equation. Now, when we talk of an ordinary differential equation is any equation which its ordinary derivative has one or more dependent variables with respect to single independent what? Variable, or one independent what? Variable. Now, this is what we mean. Before I will lay more emphasis on this, let me now clarify you on what we mean by dependent variable and what? Independent variable. I'm sure you know what differentiation means. When you differentiate y with respect to x, you are going to be having dy dx. You are going to be having what we call what? Dy dx. Or some people will put it in a shortcut, which is y prime. But I want to use this this standard one to show you the dependent variable and the independent what? Variable. Now, whenever you see any variable that is at the what? At the numerator. Now, any variable at the numerator is your dependent what? Variable. Is your dependent variable. And then any variable that you see on the denominator, no matter any kind of differential equation that you are solving, so far as that variable is on the denominator, it is called what? An independent variable. An independent what? Variable. Now, I'm sure I've been able to make declaration to what dependent and independent variable mean. But then some lecturers may talk of a known function and what? An unknown function. Now, when you talk of a known function is the independent variable. You can call it an independent variable or known function. And then the dependent variable, you can call it what? An unknown function, because it depends on the what? On the function of x to be known. To be what? Known, because x already is known. Now, let us now go deep into the example or how to give you a mathematical differentiation or mathematical difference between ordinary differential equation and the partial differential equation. Now, remember I said that an ordinary differential equation is an equation that its ordinary derivative has one or more dependent variables with respect to a single or one independent variables. Now, these are the examples. Let's assume you have dy all over dx minus y equal to exponential x. Now, How many variables are you seeing here? You are seeing a derivative of y. Now this is a variable and this is what? Another what? Variable. Now it has one or more what? Dependent variable. Don't forget I told you that what? Your dy is a dependent what? Variable. But it has only what? One or single independent variable. Now why is it called an ordinary differential equation? Because the dependent function depends on only single independent what? Function or independent variable for it to be called an ordinary differential equation. Now I'll also give another example. Let's assume we have y prime prime or xy prime prime minus y prime plus y equal to sine x. This is another example of what? Of an ordinary differential equation. Why? Because we are only having a particular independent function, and we also having what? One or more dependent function or variable. What am I trying to say? We have x here, we have x. They are one. None has been what? Differentiated. But look at the derivative or the function or the variable that is on this other part, which is for y derivative. Here we have second order derivative of what? Of dy dx. Here we have the first order, and here we have the what? The function itself, which is what? Y. Now these are one or more dependent variables, and then here we have only but one single variables. Now how do we classify a partial differential equation? Now for you to know more about partial differential equation, it is just the opposite, or it is not the opposite, but an additional what? Dependent an additional independent variable to this. Let me elaborate. Now how do we know a partial differential equation? Now you can know partial differential equation through this. A partial differential equation must not be in the form of dy over dx. No. For it to be partial, it must have something or a sign that we know as this, such as du, or let's say partial differentiation of what? Dy all over partial differentiation of what? Dx. Now this is for partial differentiation. But now let me give you an example of a partial differentiation. Now let's assume you have like the square y all over the x square is equal to c square the square y all over dt what? Square. Now don't forget what I told you. Whenever you see a function or a variable on the numerator, they are known as the what? As the independent variable. And a partial differential equation, I told you that what? These are one or more dependent what? Variables with respect to what? More than one independent what? Variables. Now what are the independent variables? The independent variables are the ones that we can find on the what? On the denominator. Now we have x here as an independent variable, and we have t here as an independent what? Variable. Automatically this turns to what? A partial differential equation. A partial differential equation. Now we will now go to classification of differential equation by order and degree. Now the differential equation can be classified by what? Order and what? Degree. Now when we talk of order, and then we talk of a degree. Now how do we differentiate, or how do we find a difference between the order and what? Degree of a differential equation? Now for you to know the order of what? A differential equation, the order of a differential equation is determined by the what? By the highest derivative. By the highest derivative. You may be asking, what is the highest derivative? I will do justice to that. Now, how do you know the degree of a differential equation? The degree of a differential equation is determined by the exponent or power of the highest derivative. Of the highest derivative. Now, I'm going to give an example to do justice to this. Now, let us check for the degree and order of this function. We have dy all over the x plus y equal to 0. And then we have equation 2. We have the square y all over the x square plus dy dx all this to the power of 2 minus y equals to sine x. And then the third one, let's check for now, having looked at each of these now, how are we going to classify and know the order or degree of what this differential equation? Now, it is very simple. I've already told you that that for you to know, for you to find out the order of this differential equation, you are looking at the highest derivative. What is the derivative? Derivative is when you say dy dx. Now, what is the highest derivative? The highest derivative that we have here is 1, because we have only dy dx. That is the first derivative. So we can say that that the order is 1. Now, how do we check for the degree? And I told you that the degree is exponent or power of the highest derivative. Now, that place that you find your order. Don't forget, you must first of all find your order before looking for your degree, because the particular place you find the order is the place you are going to check for the degree of your differential equation. Now let us look at this now. The degree of this is 1, and then our degree is 1. Now we have done justice to this one. Now I want to test you with this question. Now we have here to be the square y all over the x square plus dy all over the x, then all raised to the power of 2 minus y equal to sine x. Now what do you do? What is your highest derivative? Now our highest derivative here is the square y all over the x square, because this is the highest or the second order derivative. This one is the first order, and the rest is minor. So the highest derivative that we have here is a second order derivative. So we'll place it as order 2. Now, what is the degree? We are looking at the exponent or the power of the highest derivative. Now, some of you will come and say that the degree is 2. No, it is not 2. It is 1, because we are looking at the degree of where we found our order. Now we find our order at the square y all over the x square. So at that particular point, we will also find our degree, and our degree is also 1. So we'll have our degree here to be 1. Now this is how you do this. Now look at the third one. We have the 4y all over the x square of 4, all raised to the power of 2, plus the square y all over the x square, all raised to the power of 5, plus y equal to exponential x. We are only concerned in knowing the order and the degree. Don't forget, I said you first of all find your order, and that particular place you find your order, you check for your degree. Now, what is the highest order that we have here? The highest order is 4. Now we are going to change it. We are going to write it as order 4. Now, what is our degree? Some of you may fly and say that the degree is what? 5. That this is where we have the highest degree. No. You check for the degree on where at the place where you found your what? Your highest what? Derivative. And the degree is what? 2. So this is your degree. Your degree is what? 2. I'm sure that this example is have been able to solve or make clarification on the emphasis that or the confusion you've been encountering on order and what? Degree. Now, another point I would like us to touch is the point we have the point we call the initial and boundary value what? Problem. The initial and boundary value problem. Now, at initial and boundary value what? Problem, there is what we call the initial condition, and then there's another one we call the boundary condition. Now, how do you know an initial condition? An initial condition, we have only one specified point. You understand with an example I'll give you here. This one we only have one specified point, while boundary condition we what? The points are what? The point ranges. The points are not specified. Are not specified at 1 point. That is the point ranges, which they are trying to tell us that what the point changes from one initial position towards another. Now, how do we know an initial condition? Because this is what we are going to be encountering when we are solving calculation. So I want to do justice to each of the GSTs that we have on differential equation. Now, the next video that I'm going to hold, I'm going to teach, and then we'll now start considering some of the equations, which some of these equations or some of these explanations I'm giving here will be what required in solving those problems. Now, how do you know an initial condition? We say that an initial condition will have only what? One specified point. Let's assume you have y of 0 is equal to what? 1, and y prime, that is the y dx of what? 0 is equal to what? 5. Now, this is what they are trying to tell you. What are the specified points we're talking about? It is at what? Point 0 and point 0. But boundary condition, we have something like y of 1 equal to 2, and then y prime or y prime prime, depending on the equation they gave to you, is equal to what? 2 or 3. And then maybe they will tell you that it is equal to what? 5. Or let's use another variable as what? 6. Now, for you to be able to differentiate if it is an initial condition or a boundary what? Condition. Now, the point must be what? The same. The point must be what? The same. Just like this one started at 0 and this the other point is at what? 0. Here may be 2, here may be what? 2. It is still an initial condition. But at the point whereby the point ranges from one variable or one number to what? Another, we call that what? A boundary condition. A boundary what? Condition. Now, note this. Any differential equation with an initial condition, any differential equation with an initial condition is called an initial value problem. Any differential equation with an initial condition, such as this is a condition. So any differential equation that has this kind of condition, which is initial condition, it is called initial value value what problem. We call it the what? The IVP. The IVP, the initial value problem. And any differential equation that has what? A boundary condition is called a boundary value problem, which is a BVP. So that comes to the end of this wonderful and impactful class. If you've watched to this particular extent, do well to give me a like, subscribe, and share this video to other of your friends so that they can benefit from this. Have a nice day.